All right, so now we've cached out our particles. I'm gonna open up the parameters, make sure load from disk is on. I'm gonna go down to the group delete here and let's play back our sim. And cool, we've got this really pretty languid particle system that is emitting from the leading edges of our trails here, our little bird. So what we're going to do is we're going to start making this into actual lines and then refining those lines to be the way we want them to be. So first off, we're going to make an add, and this is going to be the object that turns these points into lines, because we have our PNT attribute that, as we remember, was created on the initial source points and then basically got propagated to every particle that emitted from those points. So we can use every particle that has that same variable value and we can connect all those together. So if I go to my geometry spreadsheet, let's highlight this. You see under PNT, if I sort by that, I have a number of points that all share 0 and then a number of points that all share all these different numbers. So what we can do is connect that to the add, go under polygons, go by group. By default, you can see it's going to wire everything together because it's going to think it's one big thing. But then we say, no, we want to wire it together by attribute, and we want that attribute to be PNT. And there we go. So now we have these really nice lines coming off those particles. Excellent. All right, so this is a good start. And now what we want to do is we want to carve these so that they're not all exactly the same length. That'll give us some nice organic variation on the ends of them. So first off, what I'm going to do is I'm going to do a reverse. I just know that the line direction needs to be reversed. So we'll do that. And this just affects the carving, just sort of like which parameter affects which end of the line, just a utility node. So next we're going to make a new attribute. So I'll do attribute create, because we're going to make basically a random number between 0.5 and 0.8 on each of these lines that we're going to use to drive the carving, so that we have an automatically created random variable for us. So I'm going to call this carve. I'm going to open up the value tab here and go expression, edit expression. I'm going to type a standard fit01 expression. So fit01 parentheses rand parentheses $PT plus 23.23. That number could be anything. It just kind of offsets the randomness even more. Close parentheses, comma 0.5, comma 0.8, close parentheses. Okay, so we've generated a random number between 0 and 1 based on the point number, and then we've ranged that between 0.5 and 0.8 within this fit01 expression. All right, so we've done that, and now we are going to create a for each subnetwork. Because we can't just enter that carve attribute directly in a field in the carve node. We've got to bury this within a for each subnetwork to work, just a quirk that we're going to build a system to work around. So I'm going to have the for each node be based on each primitive point, and I'm going to call this carver. I'm going to make it green because that's what I do with the for each subnetworks. All right, and then we're going to go inside that, and you can see that now we're just looking at one line. So this is great because we can build everything based on this one line, and then it'll apply to everything. So off of this each, we're going to make a null. I call this underscore in there. And now I'm going to make the actual node that's going to do the work, the carve. So let's look at this. So if I take my carve, let me set my first u to 0, and now my second u, you see that as I drive that, that carves the line out. This is no length, this is full length. So what we're going to do is we're going to use a point expression within this second u field to grab our carve attribute out of this little null here. So let's just do this and I'll explain it as I go. It's point parentheses, quote, dot, dot, slash, underscore in, and that just accesses the in null that we made, comma 0, because we're using a point expression. And since every point on this line has that same carve attribute that we assigned, we're just going to grab point 0. The attribute we want is carve. And since it's just a one index variable, we're just going to do 0. Okay, there we go. So now we've basically just used the point expression to access the carve attribute out of this null. So if I put the display flag on the in null, we look at the geometry spreadsheet, we see that we've got our carve. And actually we do have different values on each of these, my bad, just because of course they're driven by PNT, but it doesn't matter because we just want one of them. And so now we are going to have the output of the carve feed into a null. And we're going to have that be our final output of this chain. And now at the end of this, Now you can see that we have some nice organic random lengths of these lines. Prior to that, everything is the same length. And now we just kind of have some nice trail tails on this with our carver. So it's kind of these subtle things that can really add a nice amount of production value and organic subtlety to your geometry. So the final thing we're going to do in this video is I'm going to make a resample node, because still we've got these lines that are angular. I mean, we have an overall nice motion, but we have sort of this not pretty, sort of sharp geometry. We want these to be smoother and more languid. So I'll wire our carver into this resample. I'm going to turn off maximum segment length, but I'm going to drive these by maximum segment number. So each of these lines has the same number of points. I'm going to make that 199, which will make actually 200 points per line. And instead of treat polygons as straight edges, I'm going to make those subdivision curves. So now you can see we've gone from prior to this node. Let me turn on the point view too. We had these lines that were pretty low res and weren't that sharp and kind of low poly. And now we have these nice smooth lines that have been interpolated and have a clean point count that we know what they are. All right, so now if I play this back, it's going to be a little bit slower because we're doing this for each subnetwork that's doing each line separately. It's not the world's most efficient way to do stuff in Houdini, but it works really effectively and it's giving us our really nice lines. All right, so we've taken our particles and we've converted them into these smooth lines and we've carved them all a little bit amount differently. So we've added some more organic variation. And now we're going to move on just to completing out this trail geometry.